Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Selling your car to Carvana is as easy as...
As easy as pie?
Sure. All you have to do is enter your license plate or VIN.
As easy as a stroll in the park.
Okay, then just answer a few questions and you'll get a real offer in seconds.
As easy as singing.
Why not? Schedule a pickup or drop-off and Carvana will pay you that amount right on the spot.
As easy as playing guitar.
Actually, I find that kind of difficult. But selling your car to Carvana is as easy as...
Can be.
Visit Carvana.com or download the app to get an instant offer today.
This is SpaceTime Series 24, Episode 28. Coming up on SpaceTime, a massive supernova remnant discovered hiding in plain sight, the origin of the Zodiacal Light finally revealed, and Russia and China join forces to build their own lunar space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
By combining data from different telescopes, astronomers have discovered a massive supernova remnant hiding in plain sight. The giant remnant, reported in the journal Astronomy and Astrophysics, covers an apparent area of the sky equivalent to 90 times the size of the full moon, so expansive that telescopes were simply looking straight through it to more distant objects. Supernova remnants are massive swirling clouds of debris ejected at high velocities by spectacular stellar explosions, marking the cataclysmic death of a star. They seed the galaxy with material for future stars, and they form massive shock fronts when hitting the surrounding interstellar medium, and this can trigger new bursts of star formation. While a supernova itself is only observable on a timescale of months, their remnants can be detected for hundreds of thousands of years. So they act as cosmic signposts, pointing to where the supernova event occurred. In our own Milky Way galaxy, astronomers estimate that a supernova should erupt on average every 30 to 50 years or so. And large numbers of these remnants have been detected in other galaxies, so there should be at least 1,200 or so observable in the Milky Way today. The problem is, astronomers have only detected around 300. One of the study's authors, Dr. Natasha Hurley-Walker, from the Curtin University node of the International Center for Radio Astronomy Research, says the shortfall between the expected number of supernova remnants in our galaxy and the number that are actually identified through past surveys has been an enduring mystery. To resolve the problem, astronomers have turned to the powerful new Zeta X-ray telescope mounted aboard the joint Russian-German SRG satellite. Zeta is undertaking the first all-sky X-ray survey in a quarter of a century, and it's 25 times more sensitive than its predecessor ROSAT. So scientists were expecting to discover a new supernova remnant in coming years, but even they were surprised to see how quickly the first one appeared. Hurley-Walker says the supernova remnant was discovered almost immediately, just sitting there waiting to be seen. Following its initial detection in X-rays, the authors followed up using archival radio telescope data to confirm the discovery. The supernova remnant, which has been named Huygens, is the largest such object ever discovered by its X-ray signature. The name, by the way, is the medieval name for Bad Huygens am Rhein, which is the hometown for one of the study's authors. Hurley-Walker says the remnant was visible in surveys up to 10 years old, but because it was so high above the galactic plane of the Milky Way, it had simply been overlooked. You see, supernova remnants are not typically expected to be found at high galactic latitudes, so these areas aren't usually the focus of surveys. Of course, that means there could be even more of them there, going unnoticed, waiting to be discovered. Hurley-Walker says the radio observations suggest it's a middle-aged remnant relatively close to Earth in the direction of the constellation Hydra.
For a long time, astronomers have been able to predict how many supernova remnants we should see in our own Milky Way galaxy. And they've done this by looking at other galaxies, such as the Magellanic Clouds, which are quite nearby to us, and we can see kind of them plain on, right? We can see them laid out in front of us, and we can look at how many we find there, and we can also count massive stars. So the O and B type stars, the blue and white stars. They're the ones that tend to end their lives in massive supernova explosions. And when we count the number that we have at the moment, and we sort of assume, okay, we have a similar star history across time in the Milky Way, there should be a certain number of explosions going off. And then we can also look at how long the supernova remnants should persist. So they should last for about up to 100,000 years. And so when you look at other galaxies, when you make these calculations, and then you calculate it for the Milky Way, we predict that there should be of the order somewhere between 1,000 and 2,000 visible supernova remnants that we should be able to pick up with surveys. And having that actual number, being sure, being confident, would tell us about star formation history in the Milky Way. However, when we look up and we use sensitive radio telescopes and we build X-ray satellites and we have a look, we don't actually find that number. We've only confirmed about 300 so far. And there are lots of candidates out there. But what can often happen is someone will find a candidate at one wavelength, and then other people will look with other telescopes and they won't see anything. And so it could be that there's different kinds of populations that are visible at different wavelengths, and we need to look deeper and understand those. Or it could just be that they're not in the places we're looking. They're bigger or smaller. They are from different kinds of star formation history than we'd expect. And so this search, it's informing us about the physics of the Milky Way and the star formation history of the Milky Way, if we can eventually find all the supernova remnants.
So E-Rosetta, how does that fit into it all?
So E-Rosetta is the new X-ray satellite designed by the European Space Agency. They were originally going to put it up on the ISS, but eventually decided to put it on a standalone space observatory, which is called SPECTRE-RG, and it's run by a Russian-German consortium. And it was launched in July 2019, and then they took a few months to get up to speed. And the point of the observatory is it's not a targeted mission, so it's not observing specific objects. Instead, the plan with E-Rosetta is to do successively higher and higher sensitivity surveys of the entire sky. And that's really tremendous because we haven't had an X-ray all-sky survey in about 25 years. The last big all-sky survey was done by the ROSAT mission in the 1990s, and that is still the gold standard. When you want to find out whether your random object has any X-ray emission, you dig up maps from the 1990s. So E-Rosetta is going to be a total game changer. Fittingly, it's 25 years later, and it's 25 times more sensitive. So it's just doing an amazing job at mapping the sky. And the first pass of the survey is complete. And I think there's going to be a huge splash of papers in the next few months from science.
Where is the energy of the X-rays coming from?
Right. So when a massive star ends its life, so it runs out of hydrogen, it runs out of helium, it runs out of all of the elements that it needs to keep fusion going, it starts to implode. So the gravity of the star starts to pull the whole mass of the star inward. And this raises the core temperature of the explosion to about 100 billion degrees. It becomes incredibly hot very quickly. And of course, that's an enormous amount of energy. So the whole thing explodes outward in a massive supernova. Now, depending on the mass of the original star, you can end up with like a little core remnant that could be a white dwarf or a neutron star or even a black hole. But what goes outward is this enormous shockwave, which is one of the most energetic events. It puts the most energy into our galaxy out of pretty much anything. So supernova remnants are incredibly important for the physics of the interstellar medium because they reheat everything. They send out these big shockwaves. And of course, every element, except for a few that are produced in neutron star mergers, almost every element is produced in a supernova explosion. So the elements that then go on to form planets and, people and cabbages and kings, they come from supernovas. So the remnant goes outward, and it's of course incredibly fast moving, thousands of kilometers per second, and it starts to hit the interstellar medium. Now, as it does this, the magnetic field that came from the star originally start to compress against the rest of the interstellar medium, and you basically build up a shockwave that becomes incredibly bright in the radio. So the X-ray emission can come typically from the middle of the remnant, and you typically get this kind of radio bright shell on the outside. And what tends to happen is that the X-rays fade a little bit sooner than the radio. So most supernova remnants have been detected in the radio because it's slightly more sensitive to older supernova remnants. But sometimes you have a pulsar in the middle, and the pulsar can also put a lot of energy into the core of the supernova remnant. And then you end up with something called a pulsar wind nebula, where it stays bright in the X-rays and you have a shell that's expanding outward, but the whole thing is being reheated by the pulsar. So it can be quite complicated. The cool thing is, when you're looking at these things, you're kind of looking at a history. You can see the history of the explosion, and you can try and make a guess about what kind of explosion went off by looking at the different metals that you can see in the X-rays. But also, you're probing the physics of that part of the galaxy, the interstellar medium, which would otherwise be invisible. So you can have a look at the shape of the remnant. If it's expanding outward freely on one side and it's really compressed on the other, then you know there's actually like an invisible density gradient. And so these things allow us to kind of map out what would be otherwise a sort of invisible but hugely important component of our galaxy.
Is it difficult to tell a supernova remnant from, say, a planetary nebula? Is it scale? Is it the sort of energies we're talking about?
Yeah, so I think planetary nebulae come from red giant stars, and it's sort of a much lower mass, more gentle, sort of energized shell of nebulous gas. And I think they're very beautiful in the optical regime. You can really
very
see them.
Pretty, yeah.
Even with like a backyard telescope. The radio emission they produce is both fainter, and it has a different spectrum to supernova remnant. So the radio emission that's produced by a supernova remnant is produced by synchrotron radiation. And this is a really characteristic spectrum in the radio. It's very bright at low frequencies. And as you go to higher and higher frequencies, it gets fainter and fainter and fainter. And so this is a real sort of smoking gun for us. When we see basically a soap bubble and it has this gorgeous non-thermal spectrum, we know we're looking at a supernova remnant. And I've looked at a few planetary nebulae, and they have the opposite effect. So they're actually dimmer at low frequencies, and they're brighter at the high frequencies. So I did a survey called the Galactic and Extragalactic All-Sky MWA survey. Bit of a mouthful, we just call it GLEAM. And it was the first radio color survey. That is to say, the bandwidth was so wide that just with this one survey, you can tell the difference between things that are bright at low frequencies and dim at high, or dim at low frequencies and bright at high. And to us, they look respectively red or blue. And so for us, it's quite easy in a way to discriminate these different kinds of objects because they literally look different colors on the map, which is quite handy. Obviously, we do a more quantitative analysis, but yeah, it certainly makes it easier to pick out what we call non-thermal versus thermal emission compared to older radio surveys, which were basically in black and white.
Tell me about the early surprise.
Right, so the eROSITA satellite, that's doing a survey called the eROSITA All-Sky Survey, ERAS, and what they're doing is they're rotating the satellite and sweeping out across the sphere of the sky and building up multiple passes over the sky. So the very first survey, that is actually looked at by my colleagues at the Max Planck Institute for Extraterrestrial Physics. We have a memorandum of understanding set up through the Astronomy Australia Limited program, which allows us to work together. So I can look at my radio surveys and they can look at their X-ray surveys, and then we can work together and, see what we see. So they said, hey, we found this blob. We found this sort of surprisingly large X-ray blob, which is interesting, but we think it could be a new supernova remnant. But for us, it's just this kind of diffuse blob. And, it's a new survey, it's a new telescope. It'd be great if you could look in the radio and just give us a confirmation, one way or another. And of course, we set up this partnership to do exactly that. So I had to dig through the radio archives. And astonishingly for me, this beautiful shell-like object just, once I knew where to look, absolutely popped out. And the reason nobody had noticed before is because this object is so big, right? It's 90 times the size of the full moon. It's 5 degrees across. And so for radio astronomers, that means it's contaminated by thousands of radio galaxies, just thousands of them. You're looking out into the cosmos and you see all of these point sources contaminating the shell. And so you have to kind of already know that it's there in order to see, oh, actually, no, I do see this beautiful shell. So I did a little bit of processing and I subtracted all of the radio sources, and then I was able to measure a radio spectrum, which I mentioned, the non-thermal spectrum, this bright at low frequencies and dim at high frequencies, just absolutely popped out. And I had a look at various other radio surveys, and it turned out even surveys from about 10 years ago, you could see this beautiful shell. And there was even a signal in a survey from 1981. You could just about, if you knew where to look, you'd say, oh, okay, there it is. So it was a real example of X-ray and radio working together. I think either of us alone would have been a little bit dubious, but you put them together and you get this just gorgeous result.
So what can you tell us about it? How far away is it?
Distances are tricky for astronomers because, of course, the universe is so three-dimensional and all we get is this 2D sampling. So it could, of course, be a really enormous supernova remnant that's quite far away or a really small one that's quite close by. And so what I did was I looked through existing measurements of supernova remnants for which we have things like the size, the radius or the diameter, and the brightness, like the luminosity, so how much power is being produced. And I worked out essentially ranges for which this object could possibly have those characteristics. So there's a limit on how far away you can put it, because if it's more than about a kiloparsec or 1.5 kiloparsecs away, it becomes the largest supernova remnant ever created. And you think, it's probably unlikely that this is a truly, unusual object. So it's probably closer than that. And then likewise, it can't be closer than about 400 parsecs from Earth, because then it would have to be incredibly underluminous to be that close and yet for some reason not be much brighter, because obviously things get brighter as you move them closer. So they're able to do these sort of range calculations, and just because of where it is and how big it appears, those are actually fairly precise. Quite surprisingly, it wasn't like this thing could be on the other side of the galaxy or it could be, just outside the solar system. It was pretty tight. So it's about a kiloparsec away. And once you've got a distance away, then you know how big it is physically, because you can just sort of do some geometry. And so then I used actual physical radius that I'd calculated to do some modeling to work backwards how old it must be. Wind it backwards in time. And so it's somewhere between about 20,000 to 100,000 years old, which isn't too bad. And we think it's probably kind of in the middle age, about 40,000 years old.
Were you able to do a spectra?
So my X-ray colleagues did attempt to do some spectral measurements, but because it's quite diffuse and it's quite faint, they didn't pick up a lot of different lines. And they did some, I think it was titanium line detections, and tried to do some calculations from that. But they were actually less constraining than the radio observations.
The other interesting thing about all this is exactly where it is in our galaxy. It's not really in what we consider a busy area where these sort of things would normally be expected to happen, is it?
Yeah, so most supernovae are type 2, which means that they are the explosions of massive stars at the end of their lives. There's also a kind of supernova called a type 1a, which is when a white dwarf has a companion star and parts of that star kind of accrete onto the white dwarf, and then that causes a supernova explosion. So you get these different kinds of supernovae when in order to get a type 2 where you need a massive star progenitor, you need to have massive stars around. So typically people look for supernova remnants in the galactic plane where there are lots and lots of massive stars. So, if you're trying to build a telescope and then you're asking for, a whole year of observing to try and find supernova remnants, you don't ask for that time in a place where you're not expecting to find them. You go for the biggest bang for your buck, so you look in the galactic plane. So there have been loads and loads and loads of surveys inside the galactic plane. But this object lies nearly 30 degrees off the plane. It's really, really far. And so nobody had actually particularly noticed or been looking for them up here. And it's actually following kind of a run of new supernova remnant detections that are quite well off the plane. So I think Kothes et al. 2017 found a really nice one in the northern hemisphere. I found one a couple of years ago just below the galactic center. Kind of looks like if the Aboriginal constellation of the emu had laid a little egg. It's about 10 degrees off the plane. And then this one's nearly 30. And there's been a few others just in the last month. There's a couple papers up on Archive with the new optically detected high latitude supernova remnants. So it would be tremendously funny if all this time we were all looking for supernova remnants and then we just happened to miss a massive population that just wasn't where we were looking. So the nice thing is that most new surveys are really moving to like an all-sky paradigm. So eRosita is going to be all sky. Radio surveys that I'm working on are all sky. And so it turns out, sometimes you just find things in unexpected locations. And if we keep digging, we might find more.
That's Dr. Natasha Hurley-Walker from the Curtin University node of the International Centre for Radio Astronomy Research. And this is Space Time. I'm Stuart Gary. Still to come, the origin of the Zodiacal Light's finally revealed. And Moscow and Beijing announced plans for a joint Russian-Chinese space station on the moon. All that and much more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Data from NASA's Juno spacecraft suggests that Mars may be the source of the solar system's Zodiacal Light. The Zodiacal Light is often visible in the night sky just before dawn or just after dusk as a faint luminous glow extending up from the horizon. The glow is caused by sunlight reflecting off dust particles in interplanetary space. Astronomers have long thought that this dust is being transported to the inner solar system by asteroids and comets from much further out. But now scientists with the Juno mission have found compelling evidence that the real source of the dust is the red planet Mars. Their findings, reported in the Journal of Geophysical Research, are based on observations by the Juno spacecraft, which has been studying the Jovian system. You see, during its journey to Jupiter, Juno used 4 star tracker cameras, which are part of the spacecraft's magnetometer investigation, to snap images of the sky every quarter of a second in order to determine the probe's orientation in space by recognizing star patterns in the images. Now, one of these cameras was also programmed to look for undiscovered asteroids along the way. It didn't find any undiscovered asteroids, but it did detect thousands of tiny unidentifiable objects. Streaks suddenly appearing and then just as mysteriously disappearing. The discovery sparked initial concern that Juno might have been leaking fuel. But when scientists calculated the apparent size and velocity of these objects in the images, they realized that what they were actually detecting was sub-millimeter-sized pieces of the spacecraft's giant solar arrays, which were being chipped off by dust grains smashing into them at 16,000 kilometers an hour. Juno's expansive solar panels, each as big as a basketball court, had become the biggest, most sensitive, unintended dust detector ever built. While these tiny particles travelling at such high velocities can gouge up to 1,000 times their mass from the spacecraft's arrays, the panels themselves escaped any harm because the solar cells are well protected against impact on the back or dark side by their support structure. Each piece of debris was recording the impact of a dust particle, allowing scientists to compile a distribution of dust along Juno's flight path. Juno was launched in 2011 on a journey that would first take it into the asteroid belt in 2012, before encountering the Earth again in 2013 for a gravity assist maneuver that would finally catapult it to Jupiter. Scientists noted that the majority of the dust impacts were recorded between Earth and the asteroid belt, and there were gaps in the distribution which matched the influence of Jupiter's gravity. The dust cloud ends at Earth because Earth's gravity is sucking up all the dust that gets near it, which is seen as Zodiacal Light. Meanwhile, the outer edge of the dust belt is just beyond the orbit of Mars. It seems the influence of Jupiter's gravity is acting as a sort of orbital resonance barrier, preventing dust particles from crossing from the inner solar system out into deeper space, or from deep space into the inner solar system. The influence of the gravity barrier indicates that the dust particles are in a nearly circular orbit around the Sun, and the only object in an almost circular orbit at that distance is Mars. So, it seems Mars and its massive global dust storms are the source of this dust. The authors developed a computer model to predict the light reflected by the dust cloud, dispersed by gravitational interaction with Jupiter, scattering the dust into a thicker disk. Now, the scattering depends on the dust's inclination to the ecliptic. That's the plane around the Sun upon which the planets orbit. It also depends on the dust ring's orbital eccentricity. And when scientists plugged in the orbital elements of Mars, the distribution accurately predicted the telltale signature of the variation of the Zodiacal Light near the ecliptic. And so Mars is the source of the Zodiacal Light. This is SpaceTime. Still to come, Russia and China announced plans to develop a joint lunar space station, and later in the science report, growing evidence that the Chinese government poisoned the COVID-19 investigation. All that and more still to come on SpaceTime. China and Russia have announced plans to jointly develop a new lunar space station. The announcement comes as Moscow prepares to celebrate next month's 60th anniversary of the first manned spaceflight by Yuri Gagarin, a chance to recapture the glory days of the former Soviet Union's early domination of the space race. Of course, Moscow's space ambitions have dimmed considerably since then, due to poor economic management and endemic corruption. In fact, most of Russia's space activities over the past 20 years have actually been financed by the United States. That's because following the fall of the Soviet Union, the Pentagon was concerned about the huge number of Russian nuclear and rocket scientists who would be left without a job. So rather than allowing these scientists to be tempted to work for rogue states and those supporting terrorism, America's been financing Russia's space program. But all that's about to end, with the final nail in the coffin being America reinitializing its own manned space program by transporting its astronauts to the International Space Station from American soil instead of aboard Russian Soyuz rockets. The new proposal between Moscow and Beijing will see the Russian Federal Space Agency Roscosmos and China's National Space Administration develop an expansive manned research facility on the lunar surface. No detailed plans have been announced yet, nor has a timescale been finalised. This is SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with the Science Report. An international team of scientists have called for a fully independent forensic investigation into the origins of the COVID-19 coronavirus. It follows growing concerns over Chinese government interference and corruption at senior levels of the World Health Organization. The call, in an open letter signed by 26 leading scientists, including Australian researchers Colin Butler, Rosemary McFarlane and Nikolai Petrovsky, says the WHO report was compromised by the limitations of operating under the control of Chinese authorities. The authors point out that Beijing refused to provide key information to investigators, and the WHO team were also tightly controlled by China. They weren't allowed to go to where they wanted, they weren't allowed to interview the people they wanted to interview, and they weren't allowed to see the original data on the first cases of COVID-19. Last month, the lead WHO investigator, Peter Ben-Embarek, stated that the idea that the virus was created in or escaped from the Wuhan Institute of Virology was extremely unlikely. But that conclusion was so highly criticized by other scientists that the World Health Organization was forced to delay their plans to publish the findings. Now, that same Peter Ben-Embarek has performed a complete backflip, saying that the possibility of the COVID-19 coronavirus originating from the Wuhan lab is still one of the 4 favoured theories being explored, and it was not off the table. And to make sure there was no mistake this time, he said it twice. The sudden change happened after Ben-Embarek was forced to admit that his team had not independently verified China's claims that they hadn't done any research on the SARS-CoV-2 virus at the Wuhan laboratories. He admitted his team didn't do an audit, didn't obtain any hard facts, and didn't obtain any detailed data on the work that was done there. The scientists who penned the open letter say these key facts mean the joint team from the WHO didn't have the mandate, independence, or necessary accesses to carry out a full and unrestricted investigation into all the relevant SARS-CoV-2 origin hypotheses, whether natural spillover or laboratory research related. They say this means that as yet there is no evidence demonstrating a fully natural origin for the virus, and that the joint WHO team's processes and efforts to date have not constituted a thorough, creditable and transparent investigation. Professor Colin Butler from the National Centre for Epidemiology and Population Health at the Australian National University says politics clouded the inquiry, with Beijing being extremely defensive. It's worth noting that China supplied half the members of the WHO team. They also had approval over the other half, who would get to go and who wouldn't. And they have final say over the findings. Flinders University vaccine researcher Professor Nikolai Petrovsky says the WHO investigation simply hasn't determined where the virus originated from, and it certainly hasn't ruled out China's research labs in Wuhan as the possible source. Petrovsky says China didn't want to share all the information, so one can't rely on Beijing, and so an independent investigation is needed. He says no one knows the true source of the virus. But he stresses that it's not found in nature, and so that leaves open at least the possibility that it may have been an accidental leak from a laboratory. Petrovsky says the virus includes some very worrying features that no one's yet been able to explain, and which could easily have been put there through genetic engineering or manipulation in a laboratory. And he says science doesn't have the ability to distinguish between changes that could have been done in the lab and those that might have occurred in nature. A new study has found that there's more life than expected deep beneath the ice shelves of Antarctica. Scientists have drilled through some 900 metres of ice on the southeastern Weddell Sea, finding animals such as sponges and potentially several previously unknown species attached to a boulder on the seafloor in complete darkness and at a temperature of minus 2.2 degrees Celsius. Researchers say the discovery raises more questions than answers, such as how did they get there, what are they eating, how long have they been there, how common are these boulders covered in life, are they new species, and what would happen to these communities if the ice shelf collapsed. You can read the study in full in the Journal of the Frontiers in Marine Science. There are growing reports that Russia's new fifth-generation stealth fighter, the Su-57, is undergoing flight tests carrying hypersonic missiles. While details remain limited, the weapon's rumoured to be the new air-launched Kh-47M2 Kinzhal or Dagger hypersonic missile, reputed to have a top speed of over Mach 10, even Mach 12. The nuclear-capable missile has a range of over 2,000 kilometres and is already being deployed on Russian Air Force Mach 3-capable MiG-31 fighter interceptors and on both Tu-22 Backfire and Tu-160 White Swan long-range supersonic bombers. However, speculation remains as to whether or not the Kinzhal can fit into an Su-57's internal weapons bay. Although classified as a stealth aircraft, the Mach 2-capable Su-57 lacks the low observability cross-section of true stealth fighters like the F-22 Raptor and F-35 Lightning. Paleontologists have identified a new genus and species of Rabachiosauroid dinosaur from a fossil uncovered in Uzbekistan. Named Geratotanus kingi, the newly discovered sauropod dates back to the late Cretaceous some 92 million years ago and is estimated to have been between 15 and 20 metres long. And in case you've forgotten, sauropods are those herbivorous dinosaurs that look like Fred Flintstone's pet Dino. The ones with an elephant-like body and legs, a long neck and small head at one end, and a long tail at the other. The findings, reported in the journal PLOS ONE, are based on a single isolated vertebra. All previous records of Rabachiosauroid dinosaurs came from a narrow band extending from the southernmost tip of South America through northeastern South America and into northwestern Africa and on into Europe. Anti-fluoridation campaigners have convinced the local Port Macquarie Hastings Council on the New South Wales Mid-North Coast to spend $60,000 of ratepayers' money on a poll asking voters if fluoride should be removed from the town's water supply. But as Tim Mendham from Australian Skeptics points out, fluoride in water is mandated by the State Health Department, not local councils.
Some time ago, Port Macquarie did a survey of its population. The council did a survey and they found that a fair percentage of people didn't like fluoridation. That was about 30 years ago. And since then, fluoridation in New South Wales has been mandatory. The councils have to do it, except where the fluoride levels is actually higher than what the mandated level is, which happens as well. So with now, obviously, there's an anti-fluoride, anti-dentistry campaign, which is very, very strong in some areas. And they do a very professional job of convincing the public and convincing local councillors that fluoride is dangerous for you. And I've heard from dental people in academia and in professional dental associations who say this is a very serious issue of these anti-fluoride people convincing councils. Now, the trouble is Port Macquarie Council wants to do another survey of its population for no apparent reason, no apparent benefit, because the fluoridation is still mandatory. They still have to do it, right, for the protection of the people's teeth. And therefore a poll is just purely a artificial gesture, which is going to cost them several tens of thousands of dollars, influenced by anti-fluoride activists. And really, it's a total waste of time and very crazy. People have seen the benefits of fluoride over the last 30, 40 years. However long we've had fluoridation in water. I'm old enough to remember kids when fillings were a standard thing for kids. Half your teeth would have fillings in them. These days, it's a lot lower number than that.
As Mrs. Marsh would say, it does get in.
It gets in.
Just like the liquid gets into this chalk.
I was just talking with an academic dentist just a few weeks ago on this very topic, and he said, yeah, there's been a major change. In fact, it's hurting dentists because they're not doing as many fillings as they used to do. But still, dentists are in favour of fluoride. They know that it's a great benefit, and for some reason, this Port Macquarie Council has decided to do a poll 30 years after its previous poll to see what people of the council area think. It's not going to serve any great purpose. It might just make people upset, and it gives an opportunity for the anti-fluoride people to wage part of their leaflet dropping campaigns and things like that.
What are the arguments that fluoride is bad for you?
The only one, they suggest that fluoride causes fluorosis, which is a depleting of the enamel coating on your teeth. There's a little bit of truth in that, but you have to have a hell of a lot of fluoride to create that issue. Even the fluoride in toothpaste is not going to do it to you. So it does happen. There are various reasons why it happened, but really the amount of fluoride that goes in water is not to the vast majority of people going to cause that problem at all. So the benefits are huge on the other side, but obviously that improves sort of dental health in various ways, and dental health is pretty important to your overall health anyway. So no, the downside of fluoride is very small. I mean, despite what the anti-fluoride people will create through scare tactics.
I get the impression there's probably a strong nexus between the anti-fluoridation people and the anti-vaxxers.
Yeah, I think there is a bit of an overlap there. It's a bit, I don't know if anyone's done a survey, but I mean,
I bet you it's the same faces in both groups.
It's not necessarily. There are pretty specific anti-vax people who are high profile. They don't tend to talk about fluoride very much because perhaps it dilutes their anti-vax message. But the danger can be seen in Queensland, where had the standards sort of fluoride requirements of the councils and their tooth decay rate dropped dramatically. Then when Campbell Newman came in as Premier, he said, no, all the councils can do what they like. They're not going to have a mandatory situation. And basically fluoridation dropped to about 77%, I think it was, of local councils. And that was influenced by these same people who are anti-fluoride doing sort of their letter drop campaigns and trying to influence councillors and things. And the tooth decay level jumped up. And when there was a change of government, that mandatory was slowly coming back. It's coming back to what the percentage it should be. But the tooth decay had a big boost thanks to the loosening of regulations on councils. In the same way as you find that if the vaccination is taken away, say for measles or something, the cases of measles shoots up. So it's the same techniques used by anti-vaxxers as anti-fluoride. I'm sure there are people who share the same view, both views, but I don't know if necessarily people on the front line are the same people.
That's Tim Mindham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.